Hello, everyone, and welcome to today's InfluxDB IOx Tech Talks. My name is Caitlin Croft. Really excited to have you all here today to hear from the IOx team and what they're working on. This session is being recorded, and the recording and the slides will be made available later today. Please feel free to post any questions you may have throughout the talk, either in the chat or the Q&A. I know we're all pretty familiar with Zoom at this point. So without further ado, I'm going to hand things over to Na.
Thanks, Kaylin. Right, do you hear me?
You sound great.
Okay, great, thank you. So hi, everyone. My name is Nghe, and today I'm going to talk about the impacts of sharding, partitioning, encoding, and sorting on distributed query performance. So before go to the talk, so let's go over a bit about myself. So currently I'm a staff engineer at InfluxData. And before that, I was a manager at Tableau, which was acquired by Salesforce for 2 years on the automatic statistics. And before that, over a decade, I worked for a vertical database company. At first as an engineer in the query optimizer team, and then after that, after several years, become the director of the engineering team. And even before that, I was with a Swiss company named Enka to build software and an application. After moving from vertical to Tableau, I recognized that how much I love database and missed it a lot. So I decided to come back to database, and it's a happy place for me right now. Okay, so let's go over the outline of this talk today. So first, I will go over quickly about what is a non-distributed and distributed database. And then on the context of distributed database, how can we split the data to gain the query performance? And in that, there is different way, right? So I will talk about sharding, partitioning, encoding, and sorting, and come up with some setup of the data example for that. And then with that setup and example, I will show the impacts of those setups on the query performance. So let us look to the non-distributed and distributed database. So if you look at the top right pictures, we call it a non-distributed database, which is there's only one machine that I call it a node. So when you load the data, you load data in that node. And when you query the data out, everything goes to that node. So the distributed database just means that now we have many machines to share the work. And the bottom picture is, somehow the high level of the distributed database when you have a cluster of many machines that talk with each other, and each node plays the same role. So with that, we usually split the data horizontally between the node. And then because the data is everywhere right now, we have to query the data from all the nodes. So now we have a question with this setup, how can we split the data to gain the query performance? So here's a kind of a summary of the way we do it. So there are many ways to split the data, and this page is just a summary how we do it and the benefits of that. I will go over the one by one with the examples. So the first thing is we shard the data. Shard means like we split the data. If we have n machines and nodes, we try to split the data into n non-overlap shards. So each shard is on its node. So technically, each node will kind of equally share 1/8 of the workload. So when we load the data, right? So the first benefit is when we load the data, we just load 1/8 of the data into each node. And then on the query side, if we split them correctly, then we can join or group by the data on each node only. We don't need to move the data around. So technically, each node just share 1/8 of the workload. And the second way to split is the partitioning. So now on each chart, we will further split the data into smaller partitions for better filtering, deleting, fanning out data to the storage, and further local parallelism. And then the third way to split the kind of organize, not split, organize the data is for each partition. We can, for each column in each partition, we can further encode them. The encode is just a meaning of sort and compress the data. So it will help us with further join, filtering, group by, and order by. So there's a lot of new terms and the benefits here. So let us dig into the examples of the terms, definition, and the benefits of this. So here they are an example. So let's, in the context of you want to order something online, just you go to Amazon and you want to order something. So usually on your order, there will be, each order have many line items. So in here, so I put an example of two tables. The first table is the order, and I put the data at 5 orders with the key is 1, 2, 3, 4, 5. And then there's order, the date of the order and the priority of the order in the order table. And then the line items is how many items in each table. For example, order number 1 has 4 items, desk, chair, monitor, mouse. And then order 2 has 2 items, order 3 has 1, and 2 for 4, and 2 for 5, order 5. And then in the line item, we have 3 other columns, just the name of the items, the price of it, and the ship date of each items. And the ship date can be different for different items in the order. So with this example, let us go to the setup with the distributed data with 2 machines. That means 2 node cluster. First of all, this is show the example of how we track the data, right? How we so the order is sharded on the order key, and the line item also shard on the line items order key. And the method we do here is we do mod 2. That means on the odd orders will be on the node number 1, and on the even orders will be on node number 2. That is set up for the example. And then now we start partition further, right? So for each node, we will partition the order on order date and the line item on the ship date. So if you look at node number 1, and the order table, so the order on May 1st will go to partition, the gray partition, and the May 2nd, the order on May 2nd will go to the green partition, and similar to the line item. Then we further, sort them and encode them. So for the order table, we only sort it on the order key. So for each partition, we sort them. And for the line items, we further encode them. The RLEs, we call it a run length encoding. And in the example, you will look at the example. What the run length encoding is the way that we saw 2 numbers. Like we sort first, for each partition, we sort them on the line item order key L_order. And then if you see my mouse, I move here is this line items has the order is number 3, it's only 1 line item. So we saw the key and how many times it appears. So this one only 1, similar to order number 5, only 1 line item in this partition. But if you go down to the green partition, you will see that the order key is 1 and it appears twice in this one. So we saw 1 and 2. Similar for the pink one here, order number 1 appears 2 and order number 5 appears 1 in here. So that's how we encode. And then when you see that in the example, there's not a lot of repeats in here. If there's a lot of items with the same order, then you will see the encoding we have a lot. And let's go to examples and see. So with the setups we have here, we ask, what is the impact of these setups on our query performance? So let's go to specific example about the query we want to see. So here this query is, I want to see the total amount of the order for on certain order on a certain order on a certain day and its priority. And I only interested in the order before May 2nd and with the ship day after May 3rd. So you can see in that this day is, I want to see my, for example, in my, I'm interested in, if I'm the person who run this company, I say that I want to see the order with a high priority, that the ship day is, not the same day or not even the day after that. I want to see that to see if I can improve it. So with this query, I asked myself, do the setup we did before, do the sharks, the way we shark the data, does it have with this kind of query? So in order to answer that, I want to go back to the setup we see before. So in this setup, we shark the data on order key for both tables. And so just remind, on the odd orders will be on node number 1, and on the even orders will be in node number 2. So with that, I look at the query and I say, yes, there be the benefits. And if you look at the red highlight, right? So the first thing is about the join is query, the line items table and the order table is joined on the order key. And you see that on of the odd keys on the node number 1 and on the even keys on node number 2. So node 1 and node 2, they don't, when they do the join, they don't need to talk with each other. We don't need to shuffle the data between the nodes. We just, node 1 do work on this, on join the data on node number 1, and node 2 just do join the data on available on node number 2. And similarly, when you do the group by, right, we group data, we can group data before we send to the final destination to return the result, because we group by on the order key, and the order key is split on the odd numbers on node number 1 and not even numbers on number 2. So we just group by on each node and send the final results to the the node that we need to see the result. So then I ask myself again, what if the order is not sharded on the order key and the line item is not sharded on its order key either? Do we see the manifest, right? So the answer is, because we need to join order key on the above table, if the data is not sharded on those columns, then whatever even nodes even orders can be everywhere on both nodes. So then we have to reshuffle the data to send the same order to the same nodes. So this can be done by many ways. That means we can reshark the data on the order keys on the fly, or we have to broadcast. That means we have to send a small table, the data of small table to on other nodes. So the big table, the data can join together. So that means we need the extra step to shuffle the data before we do the join. Similar to group by, right? So if after the join, the data is sorted on, is sharded on the order key, then we every node can do the group by without resharding. But however, if the group by happens before the join, then we still need to reshard the data to have all of the nodes on the same key on go to the same nodes, or we have to send the data to on a single node at the end to do the group by. So in summary about sharding, right? So if you shard the data on the join keys of the query, then we don't need to do the action on the fly reshard or broadcast the data. Similar to group by, if the data is only sharded on the group by keys, then you don't have to reshard them and you can do the group by early. So my next question here is, with the same query, do the partitions help, right? So exactly, let's go back to our setup for the partition. So in here, we sharded the data on the order key, and we partition the data for the order on order date and on the line items on the ship day. That means on the same day will be on the same partition. So now when I look at the query, I will say, yes, the partition setup here will help us. Now, if you look at the order day, right, I highlight in red is the order day. I only need to get the order before May 2nd. And because our order is partitioned on order date, so I don't need to read the partition from May 2nd and after that. So that means I can prune the partition early. And then similar to ship day, the data is partitioned on the ship day. So I don't need to read the data before May 3rd. So that means when doing scanning, we don't need to read everything. So similar, the question is, what if the order is not partitioned on order date and line item is not partitioned on the ship date? Then the answer is there's nothing to prune, right? We have to read everything and then apply the filters. So my next question is, with this query, do the encoding and the sorting help? Okay. So I go back to the setups. The data is sorted on order key for the order table, and the line items, the data is sorted and encoded also on the line items order key. So with this, I go back to the query and say, okay, the query is drawn on the order key, and both order key is sorted. Then during the join, we will use the merge join. So if you don't know the database, usually the join is done either merge join or hash join. There are other methods, we call it next loop join, but it's not that popular. So usually merge join and hash join. And merge join can only be done if the data is already sorted, or we have to sort the data and do the merge. And then when we do the group by, because the order key is already sorted, we don't have to hash, create a hash table and then send the order key into different group before we can group. We just pipeline the data out, and when we reach the new higher value, then we just send that group, do the computation and send that group out. So similar question is, what if the order is not sorted on order key and the line item is not encoded on the line items order key? So for the join, right, because the data is not sorted, so usually we have to do the hash join, and the hash join is, through experiments, the hash join is usually slower and requires more memory than the merge join. And similar for the group by, we have to do the hash group by. That means we have to send all of the key into different groups, and when we're done with all of the table, then we do the grouping. We send the group all of the group out. And through this example, you can see that I missed this one. Is if you when you do the order, if the data is encoded in the run length encoding, we don't have to decode them. We just keep them because we know the key value and we know the number of the values in that. So we just use that and keep the data encoded. And if, and through the example, I can point thing out is if your data is, you don't have a lot of line items in the same order, then the benefits of the run length encoding won't have much. So that means the run length encoding won't have on the number, the distinct, the unique values. It should be on the values that repeat a lot. So with that, right? So we see the benefits of the sharding, the partitioning, encoding, and sorting on a single query. So we will ask now, in the system, there's not one query, there's a lot of queries in the system. How can we have a design that benefits a combination of queries? So this is the problem that's solved by something we call the database designer. That means there's a the designer that helps us to come up with a design that benefits a combination of queries. But it will be a big topic. It should be a topic of another talk. And and this is a startup named AutoTune that do exactly the same work, right? They say that they will have their custom, that the users to optimize their database to benefit the combination of the queries, and they can do it on the fly. And when your workload changes or you add more queries, it will auto-tune your work. So with that, let us go back to the slide I showed before and see what we have. We go through with the example. So the one that I underscored, that means we have the example to show the benefits. For example, for the sharding, we see clearly we can the load one end of the data is node, and we saw the benefits of the join and the group by on how we shard the data to benefit that. And then for partitioning, I did show example how you filter the data if we partition the data on the right key of the queries. And similarly for the encoding, it benefits the join and the group by. So I hope that from all of this example, you will come up with, come up with the other examples to see the benefit of deleting, fanning out the data on the storage and or local parallelism or filtering and ordering on encoding. So with that, thank you for your for joining us today, and we're happy to answer your questions.
That was awesome. Thank you so much. So, I'm sure people are, still kind of thinking of some questions, but, what can the community do to get more involved?
Yeah.
So, how can they help?
Yes. So obviously our one of the members here, our panelists here can answer that. But for me is we currently we build the data completely, not completely. We have the open source and the closed source, and on we have the server, right? So the whatever I presented here, we will build it as open source, and we put in the IOx GitHub, and the Fusion is our kind of a front end to also both front end and back end to query the data. That's also the open source that I bet Andrew can have can say something more about that.
Yeah, like Nyan says, we're a big believer in open source at InfluxData, not just IOx, the system that we've just been describing, but also the underlying query technologies. We're not putting directly into IOx entirely. Instead, we also have a significant investment in something called Data Fusion, which is part of the Apache Arrow project, which is basically a SQL query engine and optimizer and stuff. So if you want to learn more about databases or help that or work on features for SQL or whatnot, basically what we'll do is we'll contribute them to Data Fusion, and then they'll flow into IOx. So if you're at all interested, there's a big community and an active community there. So we'd love to have you help out.
Cool. And now, what excites you the most about the future of InfluxDB IOx? Why are you excited about working on this platform?
So what I think is working in the database, distributed database is always a lot of challenges, right? So data, everyone has a lot of data, and the way Influx is doing is not only solve the problems of the database, but also try to solve the problem for customer automatically, like easy to use. Like we have a front end that can on kind of a dashboard and easy, very simple query for customer. If you use FluxSQL or on kind of a Flux query, you can see that the query is extremely simple to use. And also the dashboard, we have dashboard to show customer their result. And then on the back end, that the IOx here is we try to make things super fast, right? So we can have for customer life is very easy. So I think that's a very challenges problems that I'm very interested in, and I bet like Ed, Marco, and Raphael and Andrew can have other ideas too.
Yeah, I'd say one of the exciting things about IOx is that we're going to, at least from my perspective, as someone who's been working on InfluxDB for a long time, for about 5 years, is that it feels like we're at the point now where we're going to be able to solve a lot of the sort of fundamental problems and challenges that we've had in scaling InfluxDB. So I think that's very exciting.
Cool. Yeah, it's always, I think it's great that the whole team contributes to these monthly sessions. And I think you kind of just surprised everyone. No one seems to have any questions this time. So I think they're probably still digesting what you presented. So for everyone who's still on the webinar, please be sure to check out the YouTube channel later today for the recording, as well as our website for the slides. You can always check out the InfluxDB community Slack. There is an IOx channel there in the workspace, and I know all of these amazing engineers are in there and helping answer questions. And for me personally, it's exciting seeing the IOx team just continuing to grow. I know that the community is super excited about what you guys are working on, and it's exciting to see the team grow and seeing you guys continuing to work towards getting IOx delivered. Awesome. Is there anything else that any of you want to add before we end the session today?
Thanks for hosting, Caitlin. It's great.
Always. Oh, cool. Not a question, a comment. Oh, just saying that it was very technical. I don't have anything to ask, but I love seeing these deep dives. Thanks, Chris. Happy to see you here. So yeah, we're glad to provide these technical deep dives for you. If you guys ever have any questions, if it's particularly technical or you don't think it's that technical, don't be shy to ask. We're always happy to help the community and help them understand what we're working on. Because sometimes you guys will ask questions that we haven't even thought of, and it definitely will get the team thinking about it. So, all right. Well, thank you everyone for joining today's InfluxDB IOx. I hope to see you, or IOx Tech Talks. I hope to see you next month at the next session. And once again, please go and submit your call for papers, submit your abstracts. It's always fun to get people together for Influx Days, even if we are still all virtual. Cool. Well, thank you everyone for joining today. I hope you have a good day.